Good day. This video will demonstrate the function of our WPC vending machine, modeled in MATLAB, version R 2017a. First, this section represents the connection between the user and the system. It demonstrates whether the user is connected or not. This system consists of 3 subsystems, which has their own inputs represented by constant block. They are all interconnected to a scope block that displays the output. Now we are going to take a look at each subsystem and examine their composition. First is the Wi-Fi subsystem. As you can see here, it mostly include math operation blocks and clock block. The multiplier block converts the constant input to an appropriate variable that feeds into the clock block. The additional math operation helps the clock block to properly manipulate the input. Second is the charging subsystem. As demonstrate, both charging and Wi-Fi are similar in functionality. The only difference is the value of the multiplier block. They are both designed to give an output according to the input value and the multiplier. Lastly, the printing subsystem. Inside this subsystem, it only shows the input value and the value of the multiplier block. The output of this subsystem will undergo certain operations outside the subsystem to display the expected output, based on its respective input. The reason why the main functionality of the printing is excluded from the subsystem is to display and show the necessary general information of the printing subsystem. After analyzing each subsystems, we will proceed to simulation and results. We will now demonstrate how each subsystem works. We will start by inserting a value in Wi-Fi subsystem. As you can see, we will input 5 as a value. The multiplier inside the subsystem converts the input value to a ratio of 1 is equal to 5 minutes. As shown in the scope block, the linear simulation illustrates the expected output, which is 25. This output is time equivalent to minutes. The declining line indicate the time duration being consumed. Next, we will use the charging subsystem. We will give it an input of 10. The multiplier inside this subsystem converts the input value to a ratio of 1 is to 10 minutes. As shown in the scope block, the linear simulation illustrates the expected output, which is 100. This output is time equivalent to minutes. The declining line indicate the time duration being consumed. Lastly, we will elaborate the printing subsystem functionality. This constant block indicates the number of pages being uploaded. For an example, we will put 8 as a value. The multiplier converts their input value to a ratio of 1 page is equal to 7 pesos, therefore the expected output should be 56. As you can see here in this display block, the cost is 56. This value should be met by another input constant value for printing. For example, we will put a value that will match the cost value, which is 56. Now, we will look at the simulation in the scope block. You can view the number of pages being uploaded in the scope block, which is 8 and is represented via linear simulation. Now, we will try to put an input value for printing that is less than the value of the cost. We will try 50. As you can see, this display block indicates the balance amount that the input value for printing is lacking. Now, if we are going to simulate this, and the cost value is not met by the value for printing, the output is going to be 0 as expected. That's all, everyone. Thank you for watching. God bless.